Hi there. Let's dive into one of the examples for data flow. Again, this has been taken out from a simple program. The program is very simple, but the program is near realistic. Please review the program, go statement by statement. Maybe you want to pause the video right now, ensure that you go statement by statement so you understand it. And also, maybe draw a control flow graph. Okay, so if you have actually taken a pause and drawn the control flow graph, you now know what we are trying to do. We are trying to find out the min and max from an array. That's what we are trying to do. But what are we going to make use of? We're going to make use of data flow testing. That's what we want to work on. So we're going to jump into the next DU parts. And you have the answer in front of you. What we're going to do is trace the answer, and you would see that we have also copied the piece of code over here for a ready and a quick reference. One way that you can do is actually pause and look at each of the paths that we have, DU paths for variable min, max, and I, or actually do it yourself and check the answer with what we have over here. Either way, in the end, you can come back and listen to this discussion. So let's see what we have, and I'm going to go through min, max, and variable I. So let's look at the variable max. I'm going to get rid of these inks to begin with. So what we have here is variable max. Variable max. Let's go through variable max. Yes, I found it. Variable max, and I'm going to underline everywhere where we find variable max. I find it in 2, 6, 7, 11. 2, 6, 7, and 11 is where I find. So I'm going to find out anything around 2, 6, 7, and 11. So in 2, what is happening? A D is taking place in 2. So 2 is D. 6 and 7 are use of it. Is 6 and 7 a use of it? No. 6 is definite use of it. 7 is actually a definition of it. So you would find 7, it gets defined again. Max is equal to. And ultimately, it is output at 11. But it would also be true that if it does not get into the loop, from 2, you're going to run directly to 11. And from 7, you're going to come to 11. So 7, 11, 2, 11, 7, 11, 7 and 6. How 7 and 6 is true? In the loop. So I get 7 and 6, and then 2 and 6 because that is a path that I follow in the control flow. Does this satisfy the conditions? Yes, it does. Now let's change the color. So I'm going to move the color. Let's probably use green. And let's understand variable min. So now I'm going to underline min. Oh, I see it to be a pattern. So I've got 3, 8, and 9, and 11. Also, I've got a pattern over here. I see a pattern, similar statements. So am I looking at 3, 8, 3, 11, 9, 8, 9, 11? Wow, that's what I have. The definition and use of each of them. There is a pattern between max and min. Now let's get to the third one. It's going to take a while, but we will get to the third one. We've got, let's choose another color. So let's choose blue here. So we have got blue, variable I. I'm going to start looking at variable I wherever it is. So I've got I is equal to 4. So I is here. I is here, 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 here. I is here. So what are the statements where I have I? 4, 5, 6, 7, 8 and 9, 10. Those are all the statements where I have variable I. At 4, it's a definition. At 5, it is a use. At 4, it is a definition. At 5, there is a use. At 4, there is a definition. At 6, it is again a use. I is getting used. Even 7, it gets used. 8, it gets used. 9, it gets used. 10 is again a use. Remember, I is equal to I plus 1. Do I see a pattern over here? Yes. Now I'm going to go in loops. The moment I go in a loop for the while, I'm going to get 10 and 5. So 10 and 5, 10 and 6, 10 and 7, 10 and 8, 10 and 9, and 10 and 10. I is equal to I plus 1. That's a great way of identifying. But that's part of the story. The story is completed only when you have actually designed numbers as inputs, which is N and A, to actually execute those particular paths. That is, to get 2 and 6 or to get 7 and 6, what would be required? So I have 2 and 2 to 11, 7, 6. These are the paths, and you see that we are now going to focus on some of those paths. And some of these test cases are derived out of looking at the code pieces. So test case 1 to 5. Your homework, go ahead and complete the other DU pairs. That's what we have in the example for DU pairs or data flow and data flow testing, where you first find out how the DU pairs and DU paths are and actually design test cases to ensure that we have got an input which follows that particular path from define to use. As you deduce, you will also find out that there may or may not be data with which you could reach a particular node. That is also possible. So that's what we had in data flow testing. And this concludes our topic 6.3. Thank you.